Let's take a look at average speed, average velocity, instantaneous speed, and instantaneous velocity. So we've seen that speed and velocity, those bare words, really only have meaning if we're in uniform motion. That is, they really only mean something if we're not speeding up, we're not slowing down, and we're not changing the direction of motion. But let's start taking a look at situations where we do speed up, where we do slow down, and we do change direction. So let's say that you travel 100 meters going to the west. But for the first 50 meters, you run pretty fast. That takes you 10 seconds. And for the second part of the 50 meters, you're getting a little tired, and that takes you 25 seconds. So clearly, if I asked you what the speed was, it would be difficult for you to answer that because you didn't have the same speed the whole time. Same with velocity. If I asked you what your velocity was, well, your velocity changed. So we need a quantity that will sort of average everything out. And that's why we have average speed and average velocity. The average speed is defined as the total distance that you travel divided by the total amount of time that it takes you. And the average velocity is the total displacement that you have divided by the total amount of time that it takes you. These are very similar to speed and velocity. Average speed is a scalar, and it has units of meters per second. Average velocity is a vector, and its direction comes from the displacement, and its units are also meters per second. The big difference is that these are averages. These are averaged over the entire motion. So if we were to calculate the average speed for this situation, well, the total distance that was traveled was 100 meters, and the total amount of time that it took was 35 seconds. So the average speed is 2.86 meters per second. Now, if we look at the individual speeds, so like during the fast part, the speed was 5 meters per second. And during the slow part, the speed was 2 meters per second. So the average speed is different than the speed you had at any time. It's an average of the two. And it's a little even more complicated than it might seem, because if you took the average of 2 meters per second and 5 meters per second, and you just averaged those out, you wouldn't get the average speed. The average of 2 meters per second and 5 meters per second is 3.5 meters per second. And that's not the average speed. So that's a little tricky. You have to be careful when you calculate the average speed. It's not a mathematical average where you just take the two numbers, the two individual speeds, and average them together. It's what's called a weighted average, which is a little more complicated. And we won't go into that right now. But be careful. When calculating the average speed, always go back to this equation. It's the total distance divided by the total amount of time that it takes to travel that distance. And it's very similar with average velocity. If we were to calculate the average velocity for this situation, the total displacement was 100 meters to the west, and the time that it took to travel that is 35 seconds. So the average velocity is 2.86 meters per second to the west. Let's look at another example. Let's say you travel on a bike 200 meters to the east, and that takes you 80 seconds. And then you turn around and you travel 50 meters to the west, but that takes you a little longer than you might think. That takes you 70 seconds. Maybe you're a little tired. So this is not uniform motion, clearly, because you changed direction. So we have to figure out the average speed and the average velocity. We're not going to just figure out speed and velocity, but average speed and average velocity. The average speed here, well, that's the total distance divided by the time that it takes, and the total distance you traveled was 200 meters plus 50 meters, so that's 250 meters of distance, and it took you a total of 150 seconds to do the whole motion. And that gives you an average speed of 1.67 meters per second. All right, now let's look at the average velocity. The average velocity is the total displacement divided by the time that it takes. And the total displacement, remember, displacement is just the change in position from beginning to end. From beginning to end, you traveled 150 meters to the east. and it took you a total of 150 seconds for you to complete that. So your average velocity is 1 meter per second to the east. So here we see that the average speed and the average velocity aren't always the same. It's not just a difference of one has direction and one does not. They are different quantities. One way to think about it, and there are many ways to look at this that are correct, but one way to look at this is that the average speed tells you an average of how fast you traveled on the path. So average speed ignores whether or not you change direction. It just thinks about how fast you were traveling along the path and gives you an average of that. Average velocity is a little more tricky. Average velocity incorporates direction. Because velocity is a vector, average velocity incorporates the direction. So if, for instance, in this case, you went to the east and then you went to the west, well, going to the west, because it's an opposite direction and direction matters with velocity, going in the opposite direction will lower the average velocity. It's sort of like you were to include a negative number in your average. It will lower that average. Lastly, we will look at instantaneous speed and instantaneous velocity. Instantaneous speed is the speed of something at a moment in time. Not over a period of time, but at a moment in time, at an instant. Similarly, instantaneous velocity is the velocity of something at a moment in time, at an instant in time, not over a period of time. These get a little tricky, because remember back to our definition of speed. Speed is the distance that's traveled divided by the time that it takes to travel that, and velocity is the displacement that's accomplished divided by the time that it takes to accomplish that displacement. Well, if we're looking at an instant in time, then no time passes. And these equations don't make much sense anymore, not algebraically, because during an instant, if 0 time passes, then in the denominator, we're going to have 0. That's how much time passed. That's how much time it takes in an instant. So these equations start to break down. That means that for instantaneous speed and instantaneous velocity, we need a new way to do calculations, to figure out what they are. And that is going to bring in a new type of mathematical device called a derivative, and we will look into that a little bit later.